Hello guys. So in this session we are going to learn this understanding the Helm chart structure. Okay. So let's start to understand the Helm chart structure. So first of all, in this session we are going to cover this power of Helm chart and Helm chart structure, your Kubernetes package manager, and then simplifying deployments, right? And so on. Okay. So let's start. So first of all, we need to understand the Helm. So let's introduce Helm. So Helm is a tool that automates the creation, packaging, configuration, and deployment of Kubernetes application by combining your configuration files into a single usable package. And microservice architecture, you create more microservices as application grows and making it increasingly difficult to manage. Okay. Then managing Kubernetes application across the development lifecycle brings its own set of challenges, including version management, resource allocation, updating, and rollbacks. So Helm provides one of the most accessible solution to the problem and making deployments more consistent, repeatable, and reliable. Okay, that's a small introduction about Helm. Then next is what is Helm chart. Okay. So we need to understand what is Helm chart. So Helm chart is a fundamental concept in Helm ecosystems. Okay. Then representing a package set of pre-configured Kubernetes resources. Then essentially it function as a convenient and portable way to define, install, and manage application on Kubernetes cluster. Then charts encapsulate all the necessary configuration files, dependencies, and deployment instructions needed for a particular application. And this includes YAML on configuration files for deployments, services, secrets, and config maps that define the desired state of your application. So they provide a standardized and efficient method for packaging, distributing, and versioning complex application and can contributing to Helm role as a power of package manager for Kubernetes. Okay. Then additionally, each Helm chart can version and manage independently, making it easy to maintain multiple versions of application with different configurations. Okay, so that's the Helm chart. Then next is Helm chart structure directory. So in Helm chart, there is so many files, right? When we install Helm chart and when we create Helm chart directory, then there is a multiple files. So first file is chart.yaml file. Okay. So in this file, the metadata file that plays a central role in Helm chart. So enable Helm to understand the chart, making it shareable, versioned, and easy to manage. So this is where other charts on which Helm chart that is being structured depend on the store. Okay. The next is values.yaml file. So this file in which all the values that are to be injected into the templates are defined, and similar to Terraform, values.yaml is the same as Helm variable.tf file. And the values.yaml file plays a role in Helm chart, serving as a configuration file that encapsulates default values for a version parameter used within the charts template. Then, when installing the Helm chart, users have flexibility to override the default values. So that's the values.yaml file. The next is charts directory. So this is where the other charts on which the Helm chart that is being structured depends on the store, and there might to be need to call another chart for letting the chart function properly. Then the charts directory within a Helm chart serves as a container for subcharts and other chart upon which the primary Helm chart depends. Next directory is templates. So in templates directory is a core component within the Helm chart housing Kubernetes resource definitions, and this is the folder where the actual manifest that is being deployed with the chart is put. Then for instance, for deploying an Nginx deployment that needs a service config map and secrets. Okay. Then there would be a deployment.yaml file. service.yaml file and config.yaml file and secrets.yaml file in this templates directory. So they will all their values from this values.yaml file. Okay. So in this directory, secret.yaml, config.yaml, deployment.yaml, and service.yaml file. So they will all their values from this values.yaml file. Okay. Then next is templates file. Okay. So in templates file deployment.yaml, so in deployment.yaml file, there is a contents configuration for Kubernetes deployment specifying how the application should run and scale. And service.yaml file defines the Kubernetes service, exposing the application to other services within the cluster. Then config.yaml file represents a config map, a mechanism to inject configuration data into the application. Secrets.yaml file describe Kubernetes secrets which are used to store sensitive information securely. That's the templates file. Okay. So these files and templates directly collectively define the Kubernetes resources necessary for deploying and configuring the application encapsulated by the Helm chart. The next is deployment.yaml file. Okay. So here you can see in deployment.yaml this file. So Kubernetes deployment. Here I mentioned the right Kubernetes deployment and so on. So in this file, you can see first of all API version and kind specifically the Kubernetes API version and resource kindly respectively, then metadata, then specs, replicas, selector, templates, metadata, and containers. Okay. So you can see the description of all this. The next is service.yaml file. Okay, in service.yaml file, API version, then metadata, specs, selectors, ports, type. Then config.yaml file. So the config.yaml file is often used to manage configuration settings for an application, and it allows you separate config from code and making it easier to customize the behavior of your application without modifying the application itself. Okay. Then in this values.config database.host and values.config database.port and values.config database.username and values.config.database.password are placeholder for configuration values. Okay. And this default filter is used to provide a default values if corresponding values are not specified in the Helm values file. Then secrets.yaml file. So the secrets.yaml file is typically used to manage sensitive information, as I can say, right? Then secret can be mounted as file or used to environment variables within your applications, and Helm helps manage this secret during deployment. Okay, so in this release.name is used to generate a unique name type, right? Indicates here generic secret type. Data contains the actual secret of information, right? And so on. You can see here. Here it is load the content of two files, user.txt, password.txt from the secrets directory and encodes them into base 64 and includes in the secret. Okay. Then the next is here Helm chart files. So let's see the others Helm chart file. So first file is helpers.tlp. So in this file, a Helm template file is a contain reusable template snippets and functions. So these can be shared across multiple charts for consistency. And next is requirement.yaml file. So it specify dependencies for the Helm chart and allowing you to declare other charts that must be present for the primary chart. Okay, then next.txt, sorry, notes.txt. So file containing post installation and post upgrade notes that are displayed to other after the Helm chart is deployed. Then the license, so this is the function, sorry, this file includes the license information for the Helm chart. Then readme.md file, so this file provides documentation and information about the Helm chart. Then .helm ignore, similar to .git ignore, right? Then test directory, so this directory may contain test file and scripts to validate Helm chart. Okay, right. So as you can see here, I mentioned the explanation to this file, right? Then Here you can see in in license there is a MIT license, right? That means specify a type of license. So in this case, the MIT license, that means copyright state the copyright holder of holders, right? Then permission is here by granted, that outlines to the permission granted to the user under the license. Okay. Then after that, here the test file and dot helm ignore. Okay. So then after that, you can see readme.md file. Okay. So the readme.md file is a Helm chart service as documentation to provide users with information about the charts and so on the details. Okay. After that, here replace my release with the desired release name also. Okay. So that's the release readme.md file. Okay. So that's it for the Helm chart. Okay. So first of all, we have learned here what is Helm, introduction about Helm and the Helm chart structure directory. So first of all, here chart.yaml file, values.yaml file, then charts folder, templates folder. So in templates folder, there is a few files, deployment.yaml, service.yaml, config.yaml, and secrets.yaml. Okay. The next is other help files. So here helpers.tlp file, requirement.yaml file, notes.txt, then license, readme.md file, dot help ignore, like similar to get ignore, and the test directory. So that's it from help. So in this session, we have learned understanding the Helm chart structure. So we are understanding the Helm chart structure. So thank you for watching, and I hope you understand.